we have seen that a mercury barometer has certain disadvantages. One of the disadvantages is that it is not at all portable. Also, it is a very delicate instrument, and the mercury trough is open, it is exposed, so impurities may fall in the mercury. Now, to solve these difficulties, these drawbacks, there is another barometer called as Fortin's barometer, which can be used. Let's understand the construction of Fortin's barometer. First of all, the glass tube is placed inside a brass case, which means the entire barometer is completely enclosed within a brass case. Okay, that makes it a little less delicate as compared to a simple mercury barometer. There is a vernier scale that is given for accurate measurement of height. Here you can see there's a vernier scale given here, and a vernier scale improves the accuracy of measurement of the height. That's one more benefit. In Fortin's barometer, a thermometer is also provided, which gives you the temperature reading as well. So along with the pressure, along with the atmospheric pressure, it gives you the temperature reading also. Now, this last point mentioned here is something which is very important. In case of a Fortin's barometer, the mercury is not placed in a vessel. Rather, there is a leather cup, a flexible leather cup in which the mercury is kept. Also, there is an adjusting screw at the bottom. So when I rotate the screw either comes up or goes down, depending on how you adjust that screw. Now, what is the use of this adjusting screw? Let's understand. Whenever there is a change in pressure, in atmospheric pressure, let us say the atmospheric pressure drops. Now, if there's a drop in atmospheric pressure, the mercury in this tube will fall, and that mercury which comes out of the tube will enter the leather cup. So what will happen is the level of mercury in the leather cup, this level will rise because mercury from the tube has entered the leather cup. Now, when that happens, the mercury level will rise and it will not coincide with the zero of the scale. Can you see the scale marking over here, which helps you to get the measure the height? Now, because the mercury level has gone up, it won't match with the zero. Now, what you do is you rotate the screw, this screw at the bottom, turn it and bring it down. By doing that, the mercury level will also drop down slightly. You do that till the mercury level exactly coincides with this ivory pointer. This ivory pointer. So when the mercury level in the leather cup coincides with the ivory pointer level, that is when the zero of the scale exactly coincides with the mercury level, and you can directly measure the height of the mercury column in that scale. Okay, so because the zero coincides, measuring the height becomes very easy. So that is one advantage of a Fortin's barometer. This is an improvement over the basic mercury barometer which we saw earlier. Another barometer which is commonly used is called as the aneroid barometer. The biggest benefit of an aneroid barometer is it has no liquids. So it is definitely much more portable. It does not have any liquids or a glass tube. So it is definitely more portable. No prior adjustments required. So in a Fortin's barometer, we had to adjust that screw. Nothing of that sort is required here. Let's understand how the construction of an aneroid barometer is. An aneroid barometer looks like this. And this pointer gives you the reading of the atmospheric pressure. But how does it work? Let's understand the working and construction of an aneroid barometer. In an aneroid barometer, there is a box like this box shown here. It is partially evacuated, which means the pressure inside the box is much less. Okay, there's partial vacuum inside the box. Now, the box is made up of some material which has got a springy action. Okay, so when the pressure outside, when the atmospheric pressure increases, this diaphragm, this upper surface of the box is pushed down. Atmospheric pressure pushes the diaphragm down. Okay, now when this diaphragm goes down, obviously this rod which is connected to the diaphragm will also move down. Can you see this rod has this part here which has got these teeth? These teeth. Okay, these teeth are engaged with this circular wheel which also has similar teeth. Now imagine when the pressure, atmospheric pressure rises, this diaphragm D of that springy box, that box which has got a spring action, due to increase in pressure, this diaphragm will go down. So the rod also moves down. Now when the rod moves down, this wheel rotates clockwise. Because the rod has gone down, these teeth will rotate the wheel clockwise and the pointer will then move towards the right. Okay, so an increase in pressure causes the pointer to move rightwards. If there's a decrease in pressure, exactly the opposite happens. The diaphragm will come up, the rod will come up, the wheel will turn anti-clockwise, and the pointer will move to the left. So this pointer can show you the reading of pressure. It is calibrated in such a way that it would show you the correct pressure reading. So this is how an aneroid barometer works. Uses of barometer. First use, an aneroid barometer can be used as an altimeter. What is an altimeter? It is a measuring instrument to measure the altitude. For example, an aircraft, an aeroplane, how would it know at what height it is flying? It needs to measure the altitude of the aeroplane. Now that can be done by an aneroid barometer. When you go to a greater height, an elevated height, the pressure drops. By reading the pressure, you can estimate the height that the aeroplane has reached. Okay, so it can be used as an altimeter. Second is, it can be used as weather forecasting. It can be used for weather forecasting. Okay, and this table shows you how to forecast the weather based on atmospheric pressure. If there's a sudden large drop in pressure, atmospheric pressure, it indicates a storm or a cyclone which is going to come. When there's a sudden drop in pressure, air from all the surrounding regions will come inwards towards your place. And when that happens, air coming inwards, it will bring in a lot of clouds and moisture, and that can cause a storm or a cyclone. If it's a gradual drop in pressure, it will again bring air flow towards this place, giving a possibility of rain. Gradual increase in pressure. Now, air flow will be away from your location. If there's a gradual increase in pressure, air will flow away from where you are, giving you dry weather. Sudden increase in pressure will give extremely dry weather. And if there's no change in atmospheric pressure, there'll be no change in the weather. So these are certain conclusions that you can draw based on variation in atmospheric pressure. So another use of a barometer is to predict the atmosphere, weather forecasting. Okay.